Bronwyn asked me, got it. Okay, there we go. She asked me to talk about the different winter survival strategies that we see in nature, including various forms of dormancy. And so I really appreciate the opportunity to do this. And it's forced me to learn some new things, and I hope you will learn a few new things as well. People have this notion, this kind of romanticized notion of what hibernation is. It's kind of this long, cozy, comfortable winter sleep. But the reality, if you're a hibernator, is really much different. Some of these things are right on the edge of making it or not making it, that we're going to talk about. And in hibernation is not really sleep, actually, as you might really think of sleep. In fact, if you're a hibernator, you may arouse multiple times to generate heat and to do other things where you need to have a little higher temperature. And in fact, there's some that suggest that when you hibernate, you actually have to arouse and elevate your temperature so you actually can sleep a little bit, which is a really interesting thought. And then you see this bear tucked in here. There are some people that say that bears don't actually hibernate at all. So the question becomes, and it's pertinent to what Bronwyn was talking about a little earlier, what in the world is hibernation? Well, it turns out that the answer isn't quite so simple. There are different definitions depending on what you mean by hibernation. So it all kind of depends. So to understand what I mean, I think we first should look at, we should tackle a couple of different terms that have some overlapping meanings. One term that you'll hear me use is dormancy. And both these terms, I should mention, are states of inactivity. So dormancy is a state of inactivity where basically all biological activity stops, life is maintained, but not much else is going on. And when we talk about dormancy, it can apply to any living organism. We talk about it with regard to plants as well. So it's a pretty general term. Then there's another term with kind of an interesting name called torpor. And it's something that happens in animals where there's a dramatic reduction in a lot of the life processes of an animal, metabolic rate, respiration rate, heart rate, etc., and often a loss of ability to move, ability to actually sense what's going on in the world around you, but it's a more temporary thing. And it tends to occur in response to something going on in the environment that is less favorable. It might be because of heat, it might be because of low moisture levels, it might be because of cold. So dormancy and torpor, and we'll talk about these again. Then there's another term, that's one of the terms that you will see that was mentioned in the description for the program. It's called estivation. And you could see it, estivation, with or without an A at the start of the word. And it's dormancy that happens in animals when it's dry. A lot of people think it's because of heat, but it's really when conditions get dry. And so it's more of a water conservation strategy. And one of our familiar species that at least some say will estivate during particularly dry conditions is the eastern or woodland box turtle, the very familiar terrestrial turtle that we have here in the mid-Atlantic and the central Appalachians. So estivation is not really pertinent to our discussion tonight, but that's what that is. So let's look at some definitions of hibernation. The most generic definition of hibernation is it's just a term that we apply to animals that are dormant during colder periods of the year. And this can include cold-blooded species of invertebrates like insects and amphibians and reptiles. Others say, well, that's not really hibernation. Hibernation is dormancy that occurs during colder periods of the year in the warm-blooded vertebrates. and mammals only. It excludes reptiles and amphibians and invertebrates. There is the question of the common poorwill, and do they truly hibernate, or is it just a matter of torpor? We'll get back to that as well. And then finally, some people say true hibernation is restricted to those mammals that display a complete loss of coordinated locomotory movement. They can't move. They're not really responsive. They have a dramatic reduction in all their body processes, heart rate, respiration, metabolic rates, and their body temperature really, really goes down. And we'll talk more about that as well. So these are different ways of thinking about hibernation. So, but why would hibernation occur? What is the big deal with cold temperatures? Why are cold temperatures an issue for animals? Well, there are a variety of reasons for this. For instance, as things get colder, species slow down and they become more vulnerable to predation, as well as exposure to freezing temperatures. When I was in Arizona, I take students there for spring break every year. One year we were in an area and the temperature had really dropped from the 60s and 70s down into the 40s. And we moved to rock. There was a whiptail. Whiptails are really fast lizards. And this whiptail had gotten under a rock because the temperature was such that it could barely move, and it was very much vulnerable to predation. So that's what happens when you get cold. So you better get someplace where you're safe. I don't know if you all know this, but living organisms, and that includes you and me, we are all just bags of chemical reactions. We're just like bags of stew, and we have all this stuff going on in our bodies. And the primary liquid, the primary solvent is water, okay? And one thing that happens is temperature helps mediate the rate of reactions. And most organisms are adapted for a particular range of temperatures. And if temperature goes below that range, those reactions slow, and that can alter the functioning of that animal. Furthermore, colder temperatures can modify the structure of certain important molecules in the cells. Enzymes that are these proteins that are very structurally complex, that are involved in controlling and enhancing reaction rates. And even the proteins that are in the cell membranes can be modified as things get cold. Once fluids outside the cells begin to freeze, that causes water to leave the cells. And so as it gets really cold, cells become dehydrated. And then finally, when you have ice formed, ice is not nice and round and smooth. It can be jagged, and ice can cause physical damage to cells and cellular structures. So it's not good to get cold, and it's really, really not good to freeze, okay? So what we see is, why am I not progressing here? There we go. Organisms display a variety of strategies for dealing with cold weather. They can remain active. They can stay active when it's cold. So here is the familiar chickadee. This is a black-capped chickadee, which we have out here in far western Maryland. Chickadees come to your feeder. It could be really, really cold, and they are still there. Other species leave. They migrate. They avoid the cold, and they do that by going to some place else where it's warmer and or there's more food. And of course, that's something that we think of especially in birds, but as we'll see, there's some other things that migrate as well. Here's a really a familiar species, barn swallows. Barn swallows are aerial insectivores. They eat flying insects, and if it gets cold, they are in a world of hurt. 3 springs ago in May, we had snow the second Saturday of May, and there were these barn swallows flying around in mid-30s weather through the snow and wind, desperately looking for insects, and there was a lot of mortality of swallows. That's why they migrate when it's colder. There are some animals that avoid freezing, not by leaving the area, but staying, if you will, staying locally, but moving to a place beyond the reach of freezing temperatures. Here is a wood turtle, and we have wood turtles in some of the streams in parts of especially central and west central Maryland. And in the winter, and we'll talk more about this, they go to a place where they don't freeze, and they stay safe. And so we'll talk more about that. And then there are other species that actually avoid freezing, not by going where they don't freeze, they're in freezing temperatures, but they employ antifreeze. They supercool and decrease the freezing point of their body fluids, such as a number of insects. This is a type of stag beetle that can still be unfrozen even though the temperature is below freezing. And finally, there are species, a really unique group of species that that can actually freeze in a safe manner. We'll have more to talk about with these guys. Here is a wood frog completely frozen. That's a pretty unique strategy. So there are various factors that affect organisms in terms of temperature. You know, as I said before, organisms tend to maintain homeostasis. They keep certain things in their bodies at a relatively constant level, and one of those things is maintaining thermal homeostasis, keeping the temperatures within some range so that their bodies can operate optimally. And there are various factors that affect thermal homeostasis. And if we simplify things, really simplify them, there are 3 sources of heat gain and 3 sources of heat loss that animals experience. So if you just break it down to very simple terms, animals can gain heat from the sun, either directly or indirectly. They can gain it from their surroundings, whether it's heat radiated from something else to the animal. Think about standing near a wood stove and you can feel the heat. Or heat radiated through like direct contact. So you know you gain heat very quickly if you put your hand on a hot stove, okay? So animals can gain heat from their surroundings. They can also gain heat from the chemical activity in their body. All those different chemical reactions that go on in our body involve the transfer of energy, but the transfer is never completely 100% efficient. Some of the energy is lost in that transfer, and it's lost as heat. And there's some animals that are able to take advantage of that and use that as a source of heat gain. There are also 3 sources of heat loss. You can lose heat to your surroundings. You can radiate heat from you, a warmer object, to a cooler object in your environment, or through direct contact. You know that if you sit on a cold rock or the cold ground, you very quickly get cold because you're conducting heat directly from your body to that warmer substance. A second source of heat loss is convection, and convection involves fluid moving heat away from the body. Water, and we especially think of air, like wind. That's why we talk about wind chill. And the third source of heat loss is evaporation. Now, I don't understand physics all that much, but when you have water on your surface, and it can be an internal surface, but especially we think of our skin, if that water is transferred from a liquid to a gas, that process results in a net loss of heat on the surface of your body. So evaporation causes heat loss. Now, I don't know how many of you all have read a book by a guy named Aldo Leopold. Oh, let's talk about this first. So if we put it all together, and just bear with me, I know it looks like math. Heat gain. We gain heat from some combination of the sun, from warmer objects in our surroundings, and through metabolism. And an organism can lose heat to cooler objects in the surroundings, and through convection, and through conduction. Excuse me, from evaporation. That should be evaporation, okay? So, anyhow, so if we imagine that this is supposed to be like EV for evaporation. So here is the thing. If some combination of solar radiation and heat from the surroundings and heat from metabolisms is greater than the combination of loss of heat to our surroundings and convection and evaporation, an animal's internal temperature will increase. If, however, the amount of energy or heat gained from the sun and from our warmer objects in our surroundings and from metabolism is less than the heat lost to our surroundings and through convection and evaporation, then internal temperature decreases. If the heat gain and the heat loss is the same, the internal temperature stays the same. So let's think if an organism needs to gain heat. It can gain heat, it can increase its temperature by some combination of increasing sources of heat gain and or decreasing sources of heat loss, right? You think about this, you think you get warmer by putting on a coat, right? But what you do is you increase your insulation, so you actually just decrease your heat loss, and that can cause your temperature to go up. Hopefully that makes some sense to you. So here is a famous quote from a Sane County Almanac, which was written by Aldo Leopold. And he says this, he says, I suspect, and for some reason I've got my Zoom bar, there we go, let's move it out of the way. I suspect that in the Chickadee Sunday School, 2 mortal sins are taught. Thou shalt not venture into windy places in winter, and thou shalt not get wet before a blizzard. Now, if you think about what we just learned, that makes sense. Why would a chickadee not want to get into the wind in the winter and not want to get wet? It's related to this, right? Getting in the wind increases heat loss through convection, and getting wet can lead to increased heat loss through evaporation. So if you're a chickadee and you're this tiny little guy, barely making it in terms of maintaining your temperature, anything that's going to increase your loss of heat is going to lead to your temperature decreasing. So we just think you have 3 things to play with in terms of gaining heat and 3 things to play with in terms of losing heat. And that's what every living organism has to play with in terms of maintaining or not maintaining its temperature. Another thing for us to understand is that there are 2 basic groups of animals in terms of the relationship between body temperature and environmental temperature. One such group is called poikilotherms, and a lot of people call them cold-blooded. Think about a snake, right? We think of them as being cold-blooded, but I will tell you, a timber rattlesnake sitting on a chunk of Pottsville sandstone in the Allegheny Mountains is not cold-blooded, it's pretty warm. So what we really mean is it's an animal whose body temperature tends to match the temperature of its environment. And another term for this that you will sometimes see is ectotherm, which has to do with the primary source of heat gain being external. And our ectotherms, or our poikilotherms, all the invertebrates and fish and amphibians and reptiles. So let's look at a very exciting graph, and a very well-crafted graph, I might add, that looks at the relationship between body temperature and environmental temperature in poikilotherms. As environmental temperature goes up in poikilotherms, body temperature goes up. Also, as environmental temperature goes up, the rate of metabolism goes up. So what's going on in terms of temperature and the functions of the body in a poikilotherm is all tied to environmental temperature. Now, many poikilotherms have the ability somewhere to modify their body temperature through behavioral means by changing their exposure to the sun, to warmer and colder objects of their surroundings, etc. But overall, that's the relationship. When the temperature goes up, their temperature goes up, and their rate of their functions in their body goes up. Okay? So let's look at poikilotherms here, okay? And let's look at how poikilotherms can gain heat from their environment. They can take advantage of solar radiation and from warmer objects in their surroundings and the heat that comes from them. They'll lose heat to cooler objects in their surroundings and through convective heat loss through exposure to wind, for instance, and through evaporation. So these are the things that influence their temperature. They do not have metabolism. They can't take advantage of heat generated through metabolism in any significant way to modify their temperature. So what are the strategies that are employed in cold weather by poikilotherms? Things like insects, things like salamanders and frogs, things like lizards and snakes. Well, they can't remain active when it gets cold. They can migrate. And we don't think about it, but yeah, if you think about monarchs, right? Monarchs migrate. There are just some dragonflies that migrate as well. Poikilotherms, a very common thing that they do is they avoid freezing by going to some place in their local environment where the temperatures don't reach the freezing point. And this is particularly true in many amphibians and reptiles. And there is a term that applies in at least some cases called brumation. And that's one of the terms that you saw in the title to this program. So let's talk about what brumation is. It's a period of dormancy, a period of inactivity that we see in reptiles. And I don't know whether it really applies or is used for amphibians, but it happens during colder periods of time. Reptiles have to avoid dangerously low temperatures, so they go somewhere where the temperatures aren't going to get below freezing. They will go below the frost line in the ground. They'll go deep into recesses and rocks. They'll go into a cavity in a tree because that provides insulation. Same with a hollow log. When you read accounts about different kinds of lizards and snakes, they always talk about them finding them in sawdust piles. And I think that is from back when we had a lot of logging, the turn of the last century, and there's a lot of sawdust, and it was a good place for insulation and protect these things from freezing. They could show up in your attic, right? You might have an eastern rat snake that is in your attic in the winter. You might not be excited about that, but that would be a place where they avoid freezing. Or they can go underwater. And that's a very interesting thing that we see some frogs do and many turtles do. The temperature is determined by whatever the temperature of their location is. So as long as it's above freezing, that's what their temperature is going to be. And when they go there, this is particularly interesting when a turtle goes into water, like a snapping turtle, okay? Their respiration rate decreases, so their breathing rate just decreases because they don't need as much oxygen to fuel their body. Their heart rate decreases, their metabolic rate decreases. So they have far less need for oxygen. And so even if they primarily breathe through their lungs, at this time, they only need a little bit of oxygen, and they could get it from their skin. That's what cutaneous means. They can get it from their buccopharyngeal cavity. Let's all say that together. That means the lining of their mouth and their throat. And they can even get it from the lining of their cloaca. Now, the cloaca is the common opening for waste products from digestion, from urinary products, and for like reception of sperm and release in sperm and eggs. And so basically, there's some turtles that breathe through their butt, but you didn't know that. So anyhow, they have very low requirements for oxygen. And so if they're underwater, but everything is slowed down, and they're just kind of just taking it slow. And now they may arouse during warmer weather to drink or to avoid dehydration. You read that about snakes. But this term brumation is something I had never heard of in all my, I'm in my 80s, and I never heard that term before, as far as you know. And I've taught herpetology. It's not in any of my herpetology textbooks. It's not in any of my ecology textbooks. I think brumation is a term that you hear more in amongst people that have snakes and lizards as pets. But basically it refers to this hibernation, if you mean hibernation is just being inactive during the winter, that we see in reptiles. But it's very different from what we see in mammals, okay? Another strategy that some poikilotherms employ to avoid freezing is they actually decrease the freezing point of their body fluids. It's like antifreeze. They super cool. So what does that mean? They use often molecules, proteins, or alcohols as a form of antifreeze. And that makes it so that their body fluids can decrease below 0 degrees Celsius, 32 degrees Fahrenheit, and still not freeze, okay? So in invertebrates, we see supercooling very frequently, especially insects, right? And they can use these antifreezes, but they also can depress the freezing point of the moisture inside their cells, because as the water outside their cells in their body freezes, most of the water in their cells moves out, and whatever is left doesn't freeze. So whether they employ this or they also employ these antifreeze compounds, there are some insects that can supercool up to 10 degrees below freezing Celsius. There's an Arctic beetle I read about that can supercool, still not have the fluids inside its cell freeze down to 24 degrees Celsius. That's amazing. Now, supercooling isn't a real viable strategy for amphibians and reptiles. They can supercool briefly to 1 to 2 degrees below 0 Celsius, but that's about it, okay? The final cold weather strategy we see employed in these poikilotherms is the ability to actually freeze in a safe fashion, what we call freeze tolerance. This is a pretty cool thing. And it's really interesting to me because a guy I went to grad school with is actually one of the leading experts on freeze tolerance in reptiles and amphibians. So it occurs in a small number of amphibians and reptiles, specifically frogs and turtles, and it allows them to freeze in a way that is not lethal. Now, this is best studied in a species called the wood frog. We saw a picture of it. We'll see a picture of it again. And here's how it works. They freeze, they safely freeze up to 65% of the fluids outside their cells is converted to ice. And you'll find ice in their bodies, underneath their skin, amongst their skeletal muscles. And there's a big lump of ice in their body cavity. It's pretty amazing. As this happens, the cells lose water from inside to out, and that actually protects them from damage from freezing, from ice crystals. They also produce compounds, cryoprotectants, things that protect their body from freeze damage. And as this happens, they basically go down to 0 biological activity. There may be a little bit of anaerobic respiration going on in their body. That's it. And here's what they look at. And so here's the crazy thing. When you're walking through the woods in the winter, if there are wood frogs there, they may be frozen just under a shallow layer of leaf litter right under your feet, and you may be walking on top of frog sickles. It's pretty amazing. So, what happens as things begin to warm up again? Within an hour of the temperature going above freezing, their heart begins to beat. 6 hours later, their heart rate returns to normal at only 5 degrees Celsius. And these guys can freeze and thaw multiple times. It's an incredible thing. So we see this phenomenon. We mentioned the wood frog, which in the spring, by the way, you can hear, and they sound like chuckling ducks. They go, and they're vernal pool breeders. You see this also in spring peepers. The Midland chorus frog, and I suspect in the chorus frogs, Upland and New Jersey that we have here in Maryland. You'll see this in great tree frogs. You can also see this occur in painted turtles and hatchling eastern box turtles. So what is the advantage of this crazy adaptation? What allows these species to spend the winter not way down deep in a pond or way, way below the surface, but in much shallower locations on land with minimal insulation. And they can withstand temperatures as cold as 7 degrees below 0 Celsius. Apparently, there's been no record of anything surviving below this temperature. But living and spending the winter where they are, it allows them to immediately emerge early in spring and breed. And it also, so they get a jump on all these other species, especially the frogs. They breed some of these a month earlier than some of the other frogs that we think about, like leopard frogs, like coastal plains leopard frogs. And the other thing is they can emerge and hit an aquatic environment and start to call and breed, but if it freezes, they can withstand it. So up here in Garrett County, wood frogs sometimes will come out and emerge and they'll start calling, and then we'll have 2 weeks of freezing weather. They're down there at the bottom of that and they're making it. And then when the temperature rises again, they just return to normal. So it's an incredible, fascinating adaptation that we see. So that's it for poikilotherms. But the species that we're particularly interested in, perhaps, are the ones that we refer to as homeotherms, or the warm-blooded animals. These are the animals whose body temperature stays the same, whether it's hot or cold. They maintain a constant body temperature. We often refer to them as endotherms because the primary source of heat gain is internal. And homeotherms are restricted to birds and mammals. That's the only groups that are really normal homeotherms. There's some other interesting things you find out there, exceptions to the rule, but these are two primary groups of homeotherms. And if we look at the relationship in these organisms, the relationship of their body temperature to environmental temperature, look at the blue line. Regardless of whether environmental temperature is low or high, their body temperature remains the same. How do they accomplish that? Let's look at the red line. This is metabolic rate. And as temperature decreases below some point, their metabolic rate increases to produce the heat that compensates for the increased heat loss they're experiencing at those lower temperatures. So that's what they do. So let's look at our chickadee again, okay? There are two main sources of heat gain, same as the poikilotherms, same as lizards. They can gain heat from the sun, and they can gain heat from warmer objects in their surroundings. But they can also tap into the heat produced from metabolism to augment heat gain. They face, however, the same three sources of heat loss to cooler objects in their surroundings, and convection and evaporation. So let's look at some of the strategies that these homeotherms employ when the weather gets cold. Many of these species remain active, okay? And so how do they do this? Well, let's look at that. Remember, once again, you could gain heat from the sun. So don't you think perhaps they tap into that? You can gain heat from warmer objects in your surroundings. You can also decrease the amount of heat that you lose in order to keep your temperature the same, because decreasing heat loss has the same impact as increasing your heat gain. So homeotherms, as it gets colder, in order to maintain a constant body temperature, they can reduce the amount of exposure to colder surroundings that would cause them to lose heat. One fascinating adaptation we can see in birds is countercurrent blood flow to their feet. Here is a species of Arctic gull called a Ross's gull, but this would be applicable to any other species of like duck you see in the water or bird you see perched on the ice. What is very interesting is that their arteries that send blood out to their feet are very closely located next to the veins that return blood from their feet. And you can imagine the feet are like big fins that are going to lose heat to that ice, except that as the heated blood leaves the body, it's losing heat, not to the environment, but to the blood that's returning from the feet, and it's warming up that blood. So there's far less loss of heat through these extremities than you would think, because the heat flowing out from the body to the feet is transferred primarily to the blood flowing back into the body. It's an incredible, fascinating adaptation. Another thing that organisms can do to decrease heat loss to their environment is increase insulation, and that can reduce the amount of heat through conduction to cold air. A second thing you could do to reduce your heat loss is reduce your exposure to the wind. So what you do is just find shelter from the wind. That's why a lot of birds and mammals will spend time in cavities or in burrows. And so now you've got this protection from the movement of air that's going to move heat away from your body. They can increase insulation through a layer of fat or blubber on the surface or below the surface of their body, or of course with fur or feathers. What fur and feathers do is, think about a down jacket. Inside that down jacket, you have all these little tiny feathers with all these disarticulated barbs, and it's just this all these interconnected little things that trap air. And so you have this layer of dead air where it's hard for that warm air to be moved away by the wind. And so you have what's called the boundary layer, an increased layer of still air, and it decreases the loss of decreases the movement of warm air away from the body. So we, of course, in these warm-blooded birds and mammals, they have this very effective insulation, either feathers or fur. And another thing that they may do is stay beneath the snow. Now that might sound crazy to you, but the snow is a very effective insulator. It is warmer underneath the snow than it is above the snow. One of the birds that we have, but not near as much as we used to here in Western Maryland, are ruffed grouse. And ruffed grouse, what they will do sometimes is they will actually dive down beneath the snow or into a snow layer of soft snow in the winter at night, and that provides increased insulation and reduces their heat loss. Another thing that these things will do is they will reduce their exposure to water, okay? And so that reduces evaporative heat loss. And so you may go, again, into a cavity. That's why the chickadees are more likely to stay protected in a cavity and we've got really, really cold rain, because that decreases the likelihood that they're going to lose heat. And of course, we see in birds and mammals waterproofing. So what does that look like? Well, here is a canvasback, the Lord of the Chesapeake. I just had my students down last Friday in Cambridge on the Eastern Shore at Oakley Street, a great place to see these birds up close and personal. But you could see canvasbacks swimming happily, so to speak, in super cold water, just barely above freezing. How does that work? Well, remember, they got that counter current flow in their feet that reduces heat being lost to the environment. They have this underlayer of feathers, of down feathers, which increases insulation, decreases the movement of heat away through the action of fluids, either water or above the water of wind. And above that, they have this layer of contour feathers that provides very effective waterproofing and a wind layer. And it's just the structure and the arrangement of those feathers alone that provides them waterproofing. They can enhance that by applying preening oil into their feathers, but they are basically enclosed. It's like they've got a Gore-Tex layer with down underneath them, and they are very comfortable and maintaining their temperature in the very, very cold conditions. So one of the ways that these homeotherms maintain the temperature is not just through increased heat gain, but simply by decreasing the heat that they lose. And that's a cheaper, more free way of less expensive way of maintaining their temperature, because it doesn't involve having to eat a lot of food. But they also, homeotherms can increase the heat that they gain. One way is increasing your exposure to the sun. And you have seen birds do this in the winter. You've seen squirrels do this in the winter. Probably don't increase their exposure to warmer surrounding objects as much as what we see in reptiles. And of course, the big thing of all is they increase their metabolic rate. They increase the rate of metabolism, which produces heat, okay? But this is only a viable strategy if there's enough food. If you don't have enough food, you can't. It's like if you don't have enough fuel oil or propane or firewood, you can't keep the furnace burning, okay? So being a homeotherm is a successful strategy if you have enough energy to keep the fire running. There's another challenge that homeotherms face, and that is the challenge imposed by how big or little they are, because that influences their surface area to volume ratio. So if you look here are 4 very familiar animals that you know, different species of cubes. Okay, well, I don't know of any animal that really looks like that, but it makes the math easier for us. So if you picture 4 animals, 4 species of different size, what does that size translate into that is important for maintaining temperature? Well, let's look at this. Think about, you can calculate for each of these the surface area of that cube, and you can also calculate the volume of that cube. So let's look at that. As you decrease in size, the surface area decreases, so does the volume, but at a different rate. The larger you are, the less surface area you have for your volume. As you get smaller, that ratio of surface area to volume increases. If you see what I'm talking about. Smaller, you have a much, much higher ratio of surface area to volume, okay? And so what does that mean? If you think about surface area, that's like your walls of your house. That's the surface across which you lose heat. And if you think about the volume, that relates to heat generation. It's like your furnace. So if you have larger animals, they have relatively less surface area to volume. That means they lose less heat relative to the heat that they generate by their metabolism. And they can also have potentially greater internal insulation to counter heat loss. The smaller you get, you have more and more surface area relative to volume, which means you have more and more vulnerability to heat loss relative to what you can generate via metabolism. So bigger animals, they got to eat more food, but if they can maintain their metabolism, they actually are going to lose less heat across their surface area. So one strategy that homeotherms can employ is to stay active, and we've talked about how they can do that. However, there are some homeotherms, particularly birds, and we really think of this as birds, that leave, they migrate away. Because if they don't have enough food or food supplies aren't predictable enough to fuel their metabolic rate, they can't maintain their temperature. And so what they do instead is that they leave and go to some place where that are either warmer and or where there's more food available. So that's a second strategy we see in homeotherms. What we do not see, a third strategy is to avoid freezing. Just like we saw in poikilotherms, things like lizards and snakes and frogs, you can go to a place where you're safe from freezing and give up being a homeotherm. And what you do is you let your temperature drop, okay? So that is a third strategy that we'll talk more about in a minute. Now, homeotherms do not have the ability to supercool or to freeze in a controlled fashion. So these are the three strategies that they employ. Now, we're especially interested in this last one here. So let's take a look. People have the notion that you are either active, if you're especially a mammal, or you hibernate, that there's no in between. But that's actually not the case. There's a whole gradient from species that remain active during colder temperatures to those that are fully down for the count and hibernate. Some species are active much of the time, but may occasionally go into shorter term inactivity and drop their temperature a little bit. Some species are inactive much of the time, but they do arouse more frequently and go out into the environment during the winter. And then there's some species that are dormant most, if not all, of the cold season. It's not either or. It's not a one size fits all sort of thing. In birds, most birds remain active in the winter. If they are in a cold place in the winter, they remain active, and we talked about it, and they maintain their temperature through their metabolism. But there are some species that can enter torpor, inactivity, for often just a shorter period of time, perhaps just at night. Hummingbirds can do this. Some swifts, and there's members of other groups. And then there's some species we really don't know what they do, but we suspect they may undergo torpor on cold nights. And basically what they're doing is they are dropping their temperature a little bit and they're saving energy. It's like you lowering your thermostat at night. You don't lower it so far that you can't get the house warm again the next day, but you lower it a little bit and you save a little bit of energy. That same winter, or that same May, three Mays ago, 2020, when we had snow, I watched a ruby-throated hummingbird come to the feeder all the way till dark as it was snowing and as the temperature dropped close to freezing. And I thought, what is going to happen to this bird in the morning? The next morning, I brought the feeder in so it wouldn't freeze. I set my hummingbird feeder out pre-dawn. And as soon as it started getting light, there was that bird again. And it made it. It was just fine. What did it do? It found a sheltered location where it had decreased exposure to the wind, increased its insulation, and stayed dry. And it probably dropped down its temperature a few degrees and underwent this shallow, short-term torpor to conserve energy. And the next morning emerged just fine. The swallows couldn't do it, but the hummingbirds are actually adapted to do that. The poor-will brown one is somewhere in here, but most experts say, depending on your definition of hibernation, that they don't really enter hibernation. But again, it all depends on how you define hibernation. Let's look at mammals. There's a whole range of adaptations in mammals, from species that stay fully active during the winter to some that occasionally undergo a period of activity during colder, harsher conditions. So these guys in here, to those that hibernate most, if not all of the time. And these are some familiar species. So let's look at some of these. Here's a red fox. Red foxes and many of the other predators, the other members of the dog family, the cat family, etc., are fully active during cold weather. They have excellent insulation. They will curl up to cover up those exposed bare skin parts of their bodies like their nose. And they are able to maintain their temperature under very, very cold conditions. And they do it not just through the metabolism, but by decreasing heat loss. Here is an American mink. Now, it's a member of the mustelid family. It's the weasel family. And the members of this family have a bad body shape for conserving energy because it's better to be more round and as opposed to elongated. And they spend a lot of time in water. However, they're fully active during the winter. You'll see them out in the snow. I see their tracks. You'll see them on ice. They're going into the water. They have very, very excellent waterproofing, have excellent insulation, and they're fully active during the winter. Here's a mouse. This is a American deer mouse, and many mice and voles, basically a type of mouse, remain fully active during the winter. But if you have snow cover, they stay below the snow, and so they've got that increased insulation. They will retreat at night to more insulated areas, nests, and they will often huddle with other members of the same species. And think about it, when you huddle together, it's like now you're just this one larger superorganism, and you have increased your volume relative to your surface area, which decreases your heat loss by doing it corporately, collectively. So these guys are actually active during the winter. Here's a short-tailed shrew. Shrews are tiny, incredibly high metabolic rates, very, very active, eat constantly. You would think that they would hibernate in the winter, but they don't. They're active underneath the snow. You can find them above the snow. They may undergo torpor on occasion, but they are mostly active, and they do it by just eating constantly. What about squirrels? We see them out in the winter, but you see squirrels employing a variety of adaptations to decrease heat loss. They've got insulation. You will see them facing the wind, which decreases the amount of wind coming up underneath their fur. And when it gets really lousy, they will tend to retreat to their tree nests or cavity nests or the leaf nests in the trees, which are actually pretty substantial structures. And so that they will ride out the worst of conditions. They may undergo very short-term torpor, but nothing very long-term. And you will also, by the way, see them sitting out on limbs, even when it's cold, but if it's calm, absorbing heat from the sun. So they employ an array of adaptations to remain mostly active. Here's a Virginia possum. These are not temperate zone animals. These are more tropical animals that have very little in the way of winter adaptation, and yet they're primarily active in the winter. They may hole up during really crummy times, but otherwise they're out and about. And you could tell how poorly adapted they are for this because you'll see individuals that are missing parts of their ears or their tail. They've lost it to frostbite. But these guys, they don't hibernate. Same is true with raccoons. Raccoons may become inactive and undergo kind of a shallow type of torpor during really cold weather, but they will come out and you'll see them slogging around in the snow. Same thing is true with skunks. Skunks are active much of the time during the winter, but you will notice when there is a thaw, that's when you see skunks that have been hit on the road, and that's when you smell skunks that have been hit on the road. If you've read a Sand County Almanac, Elder Leopold writes about watching or looking at the tracks of a skunk that had come out during a bit of a thaw. So skunks don't hibernate. There are some mammals that truly hibernate. Bats. Bats can be very profound hibernators. They can be you can disturb them in the winter, but sometimes when you get warmer days, you'll see, especially big brown bats, you'll see them emerge and fly around. But for the most part, they are inactive during the winter. And also, they will undergo torpor during unfavorable conditions when it's not the middle of winter. But here is an organism that really kind of fits the bill of what most people think of as hibernation. One that has always thrown me is the eastern chipmunk, because I do see them out in winter. They are so small that they can't sufficiently store enough fat in their body to keep themselves going, even with a reduced body temperature during the winter. They do hibernate, but they will awake and eat the food that they've stored in their burrows. And they will occasionally arouse, but they are considered by many to be true hibernators. They're a member of the squirrel family. So is the woodchuck or groundhog, which is considered like the classic hibernator, right? But these guys are much bigger than a chipmunk. And what do woodchucks do as summer progresses into the fall? They eat and eat and eat and eat and eat, but they're eating green herbaceous vegetation primarily. They can't store food in their burrows. They store food in their body. And before they go into hibernation, they're just they're rolling in fat. And they go down, and they literally go down for the count. A true hibernator. And then there are these guys, black bears. And are they hibernators or not? Well, let's compare a woodchuck and a black bear in terms of winter dormancy. Woodchucks in the depths of hibernation are not easily aroused, are not easily wakened. Black bears are. Our folks with the Maryland Department of Natural Resources, Wildlife and Heritage Service that go and visit black bear dens, they have bears when they go into the den that run over them trying to get out. So they do arouse relatively easy. And so they're able to move, right? Woodchucks are just, they don't move. Bears can move. Female bears give birth in their den in the winter, and their cubs are active the whole time once they're born. Woodchucks have, as classic hibernators do, a dramatic reduction in all their body functions of heart rate, respiration rate, and metabolic rates. Bears, only a moderate reduction. So they don't seem to go into that same depth of inactivity and decrease in body function. Woodchucks decrease their body temperature below 10 degrees Celsius. Black bears have a minimal reduction in their temperature, just a few degrees. What's the story with this? Well, woodchucks are way, way smaller than black bears. Woodchucks have a much higher surface area to volume ratio, so they are going to lose more heat. Bears are huge, and they store a tremendous amount of weight, of fat on their body prior to going into their den, if they even go into a den. But they have a much lower surface area to volume, so even if they are inactive, their temperature doesn't drop nearly as much. But this suite of conditions that we see for black bears make some people say they're not truly hibernators. They undergo something called winter sleep. But black bears are so good at being able to maintain their temperature because of their size. Some black bears don't go into a classic den in rocks or in the under a base of a tree. Some of them will just be under a brush pile or literally spend the winter lying exposed on the ground. And you do see them out sometimes in the winter. So are black bears true hibernators? Some say yes, some say no. You know, it's maddening to tell you this, but it just depends. It depends on what you mean by hibernation. It's not a one-size-fits-all thing. So in the end, animals display a wide range of adaptations for dealing with colder temperatures. From poikilotherms like this timber rattlesnake, that they don't mess with trying to maintain their body temperature the same in the winter as the summer. They basically retreat to some place out of the influence of freezing temperatures so that they're safe and their body temperature drops. And as things warm up, they come out, emerge from their dens, sit there at the mouth of these places and begin soaking up rays to raise up their body temperature. That's one strategy. It ranges from that to things like this northern cardinal, fully active in the winter, right? Has adaptations for minimizing heat loss, and it consumes enough food during the day to fuel its furnace to crank up its heat gain, and in the unbalance, the amount of heat gain matches the amount of heat loss, and so they can maintain a constant temperature during the winter. That's another strategy. Then it ranges to things like this. This is a woodland jumping mouse, not closely related to other mice. These are really cool animals with a super long tail. And they are maybe our most profound hibernators. There are pictures I've seen of people holding them in their hand in the winter, and they're that deep of hibernation that they don't arouse. So they give up being a homeotherm for a period of time and kind of are an honorary poikilotherm for a period of time during the winter. So the strategies vary all across the board. It's not either active or hibernate. There are all sorts of things in between. And this variety of adaptations for coping with cold temperatures is what makes this stuff so stinking fascinating. Now I want to share with you 3 books that I found particularly helpful as I got ready for this. One is this book by Peter Marchand. It's been multiple editions now, but it's called Life in the Cold: An Introduction to Winter Ecology. Really cool book. I recommend it. Plus, it's got a really cool great gray owl on the cover. This is a much older book, but still has a lot of really useful information by James Halfpenny and Roy Ozana, called Winter: An Ecological Handbook. But perhaps my favorite book of all about winter adaptations is this book by a guy named Bernd Heinrich. Was a professor at University of Vermont, has a winter cabin in Maine, and he's written all sorts of really neat books, including a couple books on ravens. But this book, Winter World, is just fascinating. And the whole premise of this book and his whole reason for writing it is based on him observing this bird, a golden-crowned kinglet, barely bigger than a ruby-throated hummingbird, fully active in sub-zero, bone-chilling cold in the Maine woods in the heart of winter. And yet there they were active, and he wondered, how in the world do they do that? And so that launched his whole book. And in the end, what did he figure out? How do they make it through the winter? You know what? He's still not completely sure. He knows there's some combination of cranking up their metabolism, maybe some nighttime torpor, there are a variety of things, but it's kind of hard to monitor golden-crowned kinglets 24 hours a day. So how they do it is still a bit of a mystery, which just makes them that much more interesting. It's kind of neat to know that there's still a lot of mysteries out there in nature, and still so much to learn. So how could you ever get bored? So there you have it, a variety of winter strategies that all sorts of animals employ to make it through the colder times of the year. So thank you all so much. Hopefully you all are awake, and I hope that you learned something, because I know I certainly learned something in preparing this. So thank you.
Thank you, Kevin. That was wonderful, and it'll be very exciting to tell my kids that I was wrong, because I'm never wrong with them, and so.
Do you remember that thing? Well, it depends on what the meaning of is. Wasn't that some famous quote? It all depends on your definition of hibernation, right? So, it's just like, I read once about people arguing with you about how to pronounce scientific names. You just give them a knowing smile. It all depends on what you mean by hibernation. So define your terms.
Right.
Yep.
Well, I did see, when I was looking up that question, there was one of the common four-wheels was tracked at being asleep for 85 days.
Yeah.
So that's what was the one that kind of said, oh.
Yeah. I've taught ornithology. I have this really great book, what is it called? The Handbook of Bird Biology, published by Cornell, and they don't technically call it hibernation; they call it torpor. Who knows, right? So.
Right, and now we can all blow our friends and family's minds with our black bear facts,
or bore them to tears. I'd be curious to know how many of you all were familiar with the term brumation. I couldn't believe that I never heard that before. I couldn't believe I couldn't find it in my herpetology textbooks. So that'd be something I'd be curious to know.
Well, that's interesting, because I guess I've heard it before, but I'm around the herp club so much, and maybe they all keep herps at home and reptiles and things, and we talk about it. Yeah. I find it. I didn't know that it wasn't in the ecology books or the
not in mine anyhow. So just fascinating. So I was really excited to learn that. And
so let's open it up. Does anybody have any questions for Kevin? You can raise your hand, and I'll call on you for unmuting, or you can put it in the chat box, and we can do the question that way. The wood frog is always so fascinating. It's just amazing. Are they?
You just don't think that that's possible, right?
No. Are they dead? It's almost like.
There's apparently some baseline level, perhaps, of activity, metabolism doesn't require oxygen. But they're just like a tick above dead. Snapping turtles in the midst of hibernation. There's a really cool book written by a retired wildlife professor from West Virginia University, about Canaan Valley, West Virginia. If you've never been there, it's a really neat place. And he tells the ecological history of Canaan Valley from the perspective of a couple of very long-lived snapping turtles. But he studied snapping turtles out there and did telemetry work on them. And he talks about these snapping turtles at the base of dams, of beaver dams and beaver ponds, where you've got flowing water. It's barely above freezing, but it's oxygen rich, and it provides them enough oxygen to stay just a tick above dead throughout the winter. And then they emerge in the spring. Yeah.
Well, that kind of is a segue into Robin's question, which says, can you tell us more about how aquatic turtle species survive the winter in Maryland?
Well, there's only one turtle that I'm aware of that spends the winter on land, and that's box turtle. And they apparently start out shallow, and they can gradually go deeper as temperatures get colder. But they do have some ability to freeze. And I've never dug out through the scientific literature to understand exactly how that works. I think wood frogs are by far the best studied, but they do display that. All the other turtles go in water. Now, they don't bury in the mud, deep in the mud, because they wouldn't get enough oxygen. It's usually on the bottom. And they could be active during very cold weather. I've read about northern map turtles, which you have, right? Just in a tiny little part of Maryland in the Susquehanna, and you could see them moving around under the ice, which just blows my mind. But as it gets colder, you're safe in the water, relatively, and your body temperature gradually drops down, which means you have less and less of a requirement for oxygen. And rather than breathing primarily employing your lungs, you employ all these other secondary modes of secondary respiratory surfaces, right? And you only need enough oxygen to do that, and that makes you through the winter. So all the aquatic turtles, do it and just really, really slow down. They don't hibernate in a homeotherm sort of sense, but they become very inactive and they avoid freezing. That's the critical thing, right? Hopefully that answered your question.
Yeah, Jenny says, do bears eat in the winter?
No. Now you see, I've seen them out and about. Brahman, were you also involved with Mayo? Do you remember the year that it met out at Rocky Gap?
Yeah,
and I took people up to Finzel Swamp. It was cold and snowy, and we saw a place where a bear had walked around and rolled in the snow, and you saw some hairs that had been, because of the cold, had been kind of caught by the snow. But bears don't eat, and they don't drink, and they don't urinate, and they don't defecate all through winter. You try that at home and let me know how that goes for you. And they develop just got to share this with you, a fecal plug, okay? And here's an interesting thing, at least up here in the mountains, one of the first things that they eat in the spring, one of the primary things they eat in the spring is skunk cabbage. Skunk cabbage actually is an endothermic plant. It's related to jack in the pulpit and it actually can elevate its internal temperature above that in the environment, which allows it to come up through that cold and icy ground. And it's out there for them to eat, but it's loaded with these calcium oxalate crystals, which if you were to eat them raw, a guy I know that apparently tried to say it was like eating rusty razor blades, but these guys will eat it. But boy, that probably be pretty effective in getting rid of a fecal plug. So yeah, that's a pretty interesting thing. In fact, there are people that have studied this phenomenon in black bears, trying to understand what we might do to allow people to travel for very long periods of time while inactive in space. Black bears, yeah. And remember that terrible chocolatey space stuff that you got in a wrapper in the 60s? You don't, but anyway, I do. And you wouldn't even need that or Tang, right? You would just not eat anything. I'm aging myself.
Wow. And so let's see, the sun breeds snakes and taught us about the term brumation. And Jillian says that bumblebees are,
yes.
and honeybees also stay used their metabolism.
Right. And are they fully ectotherms or, but there are some of these insects that can begin to work their flight muscles and generate heat from that. There are some, and you'd see, would you say, leatherback sea turtles, right? And there's some fish that are basically homeothermic, or at least leatherback sea turtles, they may maintain their core temperature, but not maintain their external temperature. So there are some, and I'll tell you, that's how ecology works. For every rule, there's an exception, right? But these are kind of exceptional species. Right, and that's interesting that you mentioned that they are massive. Yeah, and I don't know the answer to all that. It's really cool. But you're right. There are some exceptions in both the invertebrate and the vertebrate world, but the vast majority of these ectotherms or endotherms, these homeotherms, are birds and mammals.
What time of winter do bears give birth? And I guess they're lactating even though they're not doing any other stuff.
Yeah. I want to say January. A bazillion years ago, I had the opportunity to take some students out to where the state was visiting a den, and this was in early March. And by that time, these bears were, that's not going to make, they were less less than a foot long. And you know, I'm a you know, a veteran biologist, but they were cute. And my wife's favorite picture of me all the time was when I was younger, skinnier, and holding a black bear cub. But yeah, I want to say January. So I mean, they're probably giving birth now. But the amazing thing is, some of them are doing it with very little shelter. There are pictures, you can find pictures of sows with cubs lying on the ground. It's incredible.
Let's see, what was the name of the book about the Canaan Valley?
Okay, yeah. It's either called A Land or A Valley Called Canaan. Now, this is the West Virginia pronunciation of Canaan, Canaan. And it was written by, it'll either be listed as Ed or Edwin, W-I-N, Michael. It's just a fascinating book. And since I know him, I just see his personality through it. And it's interesting, it's entertaining. Yeah, E.D. Michael, there we go. Yeah. So, and there's a really cool story at the end about his encounter, or this biologist's encounter with a snapping turtle in the dead of winter and what happened. And I won't tell you anything about it, but it's fascinating and it's funny. And I asked him if that was autobiographical, and in his characteristic way, just kind of, So anyhow, it's a neat book to read. Yeah, if you get a chance to get it, check it out.
Vanessa asks, how did the bears lactate if their metabolism is mostly shut down?
But their metabolism is maybe, and I should have notes on this. What is it? Hang on. I have some notes on this. Because remember, it's not shut down nearly to the degree that a woodchuck is. Metabolic rate is about 50 to 60% of normal in black bears. Heartbeat drops by about 75%. Yeah. So they're able to do that. So they don't shut down. And that's a good point. I never really thought, I mean, they give birth, but they also lactate during that time. So bears are just different. But is it that they are totally different, or it's just that they're really big? You know what I mean? Are they doing things totally differently, or is it just some degree of hibernation? And different books tell you different things.
And let's see, Jillian follows, it says a theory about dinosaurs,
Right.
says that becoming homeothermic could burn up the excess calories as they became massive.
Right. Yeah. So then that's which came first, the homeotherm or the bird? Right. You know, if they came from dinosaurs, that's pretty interesting. Never having witnessed a homeothermic dinosaur without feathers, I don't fully know how that works, but you know, the herpetologists don't think birds are special. They just think they're a aberrant group of reptiles. So
yeah. Do captive woodchucks hibernate if they kept warm?
That's a great question, because you know, so many seasonal activities are cued not by what they ultimately are affected by, like temperature, because it's variable, right? But it's affected by change in day length, right? But even in the absence of that cue, many animals still maintain through that internal biological clock some seasonal timing for a period of time before it kind of gets off track. And I don't know. Now I know obviously Punxsutawney Phil does, and there was a woodchuck in Cumberland, Maryland, that at the now closed zoo, that was Murray or something, anyhow, that they would do a local thing with, and he obviously, actually, I don't know if he hibernated. Maybe he was active and they just dragged him out and pretended like he'd been hibernating. Ask Bill Murray how that works. He'll be able to tell you, right?
Well, and I know that I mean, in the Herp Club, there's always conversation about, am I gonna let my guys or gals hibernate this year or not, and things like that, so that they regulate that through the temperatures and things. So.
Yeah, and that's a whole thing that I've never. I can't take care of myself, so I certainly can't take care of a lizard or a snake. That's just too much work. So I've never had to figure that stuff out, and that's a whole culture in and of itself. And so that was what makes me wonder whether the term brumation kind of arose. I don't know. It was just such an interesting thing.
So Mary asked earlier on, are researchers seeing a different pattern with climate change?
Well, that's a great question. And for so many seasonal activities, the rate of change is faster, perhaps, than the rate of adaptation to that change. And so the timing could be off. If you've read the book, World on the Wing, I think it is the newer Scott Weidensaul migration book, which is a great book. For my students that think all about the thing you do with birds is try to count as many as you can, I say, read this book. This is what it's all about. But he talks a lot about in different places about how the timing of migration and different things may now be out of sync with what's going on environmentally. Things arriving too late or too soon, and yeah, and I, we'll see.
And what you didn't mention anything about a hibernaculum,
right?
With snake.
Right.
Is that because they all gather together, but not in the winter, they don't like being next to each other.
Well, yeah, I mean, and right, but that's true for a lot of things, right? There's species of bird, like think about the robins and the red-winged blackbirds. As long as it's cold or snowy, they're hanging out together. As soon as it warms up, they're yelling at each other, and then you get another snowstorm, they're back together again. But yeah, I mean, when we talk about, like with the hibernaculum, is that recess, that safe place where they go, whether as individuals or like those garter snakes in Manitoba in huge masses, hibernaculum. And there you go. We're using the term we're using that same term for a phenomenon that people say isn't hibernation, but it's hibernia is winter. It's a place of winter, right? So that's really the root of it, I guess.
Yeah, the etymology is just the Latin word for winter, not, and
yeah. Right. It's not inactivity. Yeah. Yeah.
All right.
Well, I'm able to pontificate on all sorts of stuff I know nothing about. This is fun. So.
Any other questions for Kevin while we have him at our beck and call right now? Otherwise, he's going to go. We're all going to go hibernate or torpor or brumate or everything.
Or just get some supper is what I'm going to do. So.
Right.
Anyhow.
Or go to sleep.
I could do that. Thank you all so much. I really appreciate you hanging in here with me, and I just appreciate, Bronwyn, what you do for our naturalist community, particularly down there in the more populated area of the state. So, and I do look forward to the time where we might get you folks coming out here and we can show you, a really, really cool part of the state, literally and figuratively, right? So thank you so much. I appreciate the opportunity.
Thanks, Kevin, and we're coming. So be, we're coming your way.
Thank you. Take care, everybody.
All right. Take care. Bye-bye.
Bye.
Stay well. Stay curious, everybody, and stay outside. Bye-bye.